So, you're pretty comfortable pulling data from databases, right? You can query what you need. But what about that next step? How do we start predicting things that haven't even happened yet? Well, that's the perfect place to start. In this explainer, we're going to build up a solid foundational understanding of predictive modeling.
All right, so here's the game plan. We're going to walk through 4 key ideas, starting with the absolute basics of regression, and then we'll work our way all the way up to how we figure out if our predictions are any good.
Okay, let's start at the beginning. Before we can even think about predicting the future, we have to understand the relationships that are hiding in our data right now, and that's exactly where regression comes in.
So, to kick things off, what is regression analysis really? What's it all about, and how does it help us find the story that our data is trying to tell us?
At its heart, it's really just a way to figure out the mathematical relationship between variables. You've got one thing you want to predict. We'll call that y. And you want to see how it moves when other things, our x variables, change. Now, this is something that can definitely get confusing. Depending on who you're talking to, an engineer, a statistician, they'll use different words for the exact same concepts. But don't let it trip you up. It all boils down to the same thing: the variable we're trying to predict and the variables we're using to predict it.
Okay, so that basic idea of regression is great, but it has its limits, right? Let's talk about how we can move beyond that into something way more powerful and flexible.
I mean, it's fantastic for predicting something like, say, a house price, which can go up or down smoothly. But what if the thing you're trying to predict isn't like that? What if you're predicting the number of clicks on an ad? You can't have half a click, right? Or something else with a built-in limit.
And that, right there, is where Generalized Linear Models, or GLMs for short, come into play. Honestly, these things are a total game changer, a real workhorse in any data analyst's toolkit.
So here's what makes them so awesome. First, you're not stuck with that classic bell curve output anymore. You can model all sorts of things like counts or binary outcomes. And second, there's this clever piece called a link function. Think of it like a translator. It connects our inputs to the output, even when the relationship isn't a simple straight line.
The big takeaway here is that GLMs just open up this whole new world of prediction problems. So let's talk about maybe the most common one of all, predicting a simple yes or no.
Yeah, this is super powerful. But it brings us to a huge business question we face all the time. What about predicting a choice? Is a customer going to churn? Yes or no? Is this email spam? Yes or no? That kind of stuff. You nailed it! And for that exact problem, there's a special type of GLM called logistic regression. What's so cool about it is that it doesn't just spit out a yes or no. Instead, it gives you the probability of something happening. So you'll get an answer like, there's an 80% chance this customer will churn. And how does it do that? With that special link function we mentioned, this one's called the logit. Now, don't let the formula on the screen scare you. All it does, its whole job, is to take the result from our model and cleverly squish it so the final answer is always a number between 0 and 1. And a number between 0 and 1 is a probability. Pretty smart, right?
All right, so we know how to build a few different kinds of models. But now comes the really important part. How do we know if our model is any good?
Exactly. A model is completely useless if its predictions are bad. But here's the thing. Error isn't just one simple concept. We need to break down the different ways a model can mess up.
So, it turns out you can break down a model's total error into 2 main components that we can actually influence, something called bias and something called variance. And honestly, learning to balance these two is one of the biggest challenges in all of machine learning.
Let's break that down. Think of bias as the error you get when your model is just too simple. It makes the wrong assumptions and completely misses the real patterns in the data. We often call this underfitting. Then you have variance. That's the opposite problem. The model is too complex. It starts memorizing the random noise in your training data instead of the actual signal. We call that overfitting. And this brings us to what's famously called the bias-variance dilemma, or tradeoff. See, a really flexible, complex model will probably have low bias. It can capture anything, but it's at super high risk for high variance, for overfitting. On the flip side, a simple model will have low variance for sure, but probably high bias because it's too rigid. The tricky part is, you can't get rid of both at the same time. You have to find that sweet spot.
So that leaves us with a really practical question for your next project, right? Should you start with a simple model that might be a little bit wrong, or a super complex one that might just be chasing noise? It's a tough call, and there's no single right answer. It really all depends on your data and what you're trying to achieve.
We hope this explainer helped clear things up and gave you a solid foundation in predictive modeling.
Thanks so much for watching.